Assalamualaikum and good day. My name is Mohd and Hafidz, Taslim, CD19140, and in this project I'm going to explain briefly about our group project, which is water classification using fuzzy logic algorithm. First of all, the objective of this dataset itself is to determine either the water from the samples, from thousands of samples, can be drink by humans or not. Is it safe for human consumption, or is it the opposite? So to know if humans can actually drink that water, we need to consider some attributes. In this dataset, we have 9 attributes in total, and those 9 attributes are pH, hardness, solids, chloramine, sulfate, conductivity, organic carbon, trihalomethanes, turbidity, and potability. So those are all of the attributes that are contained inside the dataset. But in this project alone, we are going to focus on only four attributes for those dataset. 4 of those attributes are pH, chloramine, organic carbon, and turbidity. So why are we focusing only on 4 attributes? The reason for that is because these 4 attributes are well enough to actually determine either the water is safe or not for human consumption. Other attributes are important as well, but we could keep them aside. And also for when it comes to developing the project, those attributes will be difficult to implement inside the project. So for now, we are going to focus mainly on these 4 main attributes. For the dataset, we have gotten the CSV file from Kaggle. It is accessible online, and these are the screenshots for some of the examples of the real dataset in the Kaggle website. And as for the methodology, the framework, the fuzzy logic framework for this project is quite simple. There's only three main modules. Those modules are attributes, fuzzy logic model, and the output. And then there are 2 in-between modules between those 3 main components, which are fuzzification and defuzzification. Inside the attributes, we will insert the 4 main inputs, which is pH, chloramines, organic carbon, and turbidity. Those inputs will be transferred into the fuzzification module, and then we'll be going on some process inside the fuzzy logic model, which implements the rules and then the inference. And then after it has been processed, it will go through on the defuzzification process, and finally we would have the output, which is potability. The potability itself would tells us either the water is safe or not based on the binary output, which is 0 and 1. If it is 0, it's not safe to drink. If it is 1, it is safe to drink. And that is all for the brief explanation on how this project will be done, and the framework itself, and then the dataset for this project. I will be giving this presentation to SYAMIM to explain on the membership functions and so on. Thank you.
Assalamualaikum and hi. My name is Muhammad Syamim AIMAN bin Muhammad Sam with matric ID CHEAH 21035. It's really important for us to choose a safe drinking water. Water can help our bodies in 4 ways. It can speed up our metabolism, make our skin healthier, help us lose weight, and keep us alert. There are several factors that needs to be emphasized for get the safe water quality for drinking. Now, since our project is about water quality, we need to study how to get potability of drinking water. In our project, we are using 5 membership functions, including an output. We are separate for membership functions for input and 1 for output. The input membership function consists of pH level, chloramines, organic carbon, and turbidity, while an output is potability for safe drinking water. Next, we are using fuzzy conjunction, which is fuzzy and to construct fuzzy logic rules. There are 4 fuzzy logic rules for our project. Rule number 1, if pH is acidic and chloramines are safe, then potability is false. Rule number 2, if carbon is low and turbidity is clear, then potability is true. Rule number 3, if pH is alkaline and chloramines are harmful, then potability is false. Rule number 4, if carbon is high and turbidity is opaque, then potability is false. Thank you.
Hello, my name is WILFRED, Metro ID CB20028, and I will now explain our findings, our results for this project with the water quality dataset. So we have done a total of 4 sets. We have tested a total of 4 sets with 4 chosen attributes, which are pH levels, chloramines, organic carbons, and turbidity. And our output is potability, where we have assumed that 0 is equals to false and 1 is equals to true. So in the total of 4 sets that we have done, the output are shown in the graph below. So for set 1, we have tested with a pH level of 3, chloramine 6, organic carbon 5, organic carbon 15, turbidity 4, and our result is 0 for potability. For set 2, we had pH level 6, chloramines 4, organic carbon 11, and turbidity 3. Our output is true, which is 1, which stands for true for potability. In set 3, the input is pH 7, chloramines 5, organic carbon 7, and turbidity 4. The output for this set is 1, which is true. And finally, the fourth set, we have put an input pH 9, chloramine 6, organic carbon 13, and turbidity 5. So the result we have gotten is 0, which is false for potability. So we have also done a table of comparison to show to compare the actual output, which is provided by the dataset, and the system output. So as just now stated, our system output is false, true, true, and false for set 1 to set 4 respectively, and the actual output is false, true, true, and false. So since we assume that true is equals to 1 and false is equals to 0, we can calculate the error percentage by using a formula where actual output minus system output is divided by actual output times 100%. So based on the graph shown, we can find out that there is no difference between the actual outputs and the system outputs. So it means that there is no error with the accuracy of the system. So in conclusion, there is no error percentage of the fuzzy logic system compared to the dataset provided. I will now explain about the coding part of this report. Okay, first, we input the fuzzy control API. After that, we declare the functions, antecedents on consequence objects to hold the variables and membership. Next, we create the membership functions for pH, chloramines, organic carbon, turbidity, and potability. So next, we view to check if the graph is correct or not. So as you can see, we have the pH graph, we have the chloramines, we have carbon, and turbidity. So after that, we declare 4 rules, which is if pH is acidic or chloramines is safe, then potability is false. For rule 2, if carbon is low or turbidity is clear, then potability is true. Rule 3, if pH is alkaline or chloramines is harmful, then potability is false. Next is rule 4, if carbon is high or turbidity is opaque, then potability is false. So we view the rules like this to see the connection between the rules. Next, we declare the control system simulation for the rules. Next is our inputs, where we take the data from the dataset and then we compute, and this time view the output. So as you can see, for the inputs above, for pH is 9, chloramines is 6, carbon is 13 and turbidity is 5, we get the output false. That's all.